All right, so we are at inverse equations, and we're at verifying inverses, okay? There are two ways to determine if two functions are inverses of each other. There's graphically and algebraically. All right, so we're going to quickly talk about graphically. When you are doing it graphically, it's literally having that y equals x line in. So if you graph y equals x, and the points are symmetrical around y equals x, then they are inverses of each other. That's graphically. Okay. And then you're checking the points. So this one is we're at 1, -1. And so therefore this should be at -1, 1. Is it? Yes. This point is at 1, 2, 3, 4, 5, 5, 0. This point is at 0, 5. Okay. If you're given the graph, that is all you're doing to verify that they're inverses. Easy enough? Questions, comments, or concerns about that? All right, so let's look at it ourselves. So here, it says determine if the two functions are inverses by graphing. This is a linear. You should be able to graph a linear without a calculator because you're in Algebra 2. So we're going to graph our linears without a calculator. We have 1/3 x plus 2, and we have 3x minus 2. Here's my y-intercept. Here's my slope. My y-intercept tells me where I began. My slope is my map that tells me what direction I'm going in, right? So I'm going to go to +2. At 2, I'm going to rise 1 and run 3. Rise 1, run 3. Rise 1, run 3, and vice versa. Now, to do the other side, I'm going to fall, then crawl. So I'm going to fall 1, crawl 3. Fall 1, crawl 3. Fall 1, and crawl 3. I graph my linear. So this is f of x. Now it wants to know if g of x is its inverse. So now I'm going to do the same thing. Here's the slope. Here's the y-intercept. So this time I'm beginning at -2, and my slope is 3/1. So I'm going to rise 3 and run 1. So I begin at -2. I'm going to rise 1, 2, 3 over 1. 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 To do the other side, I'm going to fall 1, 2, 3 and crawl. 1, 2, 3 and crawl. And now I'm going to graph it. Connect my points. Now I'm not drawing the very straight line, but try my best. Okay? Not in this program. All right, so now it's asking, are these symmetrical around y equals x? So if I draw y equals x, in there, are they symmetrical? Nope. So are they inverses? No. Okay. So no symmetry, not inverses. Okay. How do we feel about graphically determining whether two functions are inverses? Okay. Questions, comments, concerns? All right. On the back, we're going to do it algebraically. Algebraically, we talked about before composition. We have to plug one function into the other, and the goal is to get x. If you do not get x, then they are not inverses of each other. Okay, so we're going to substitute g of x into f, and then f of x into g, and the goal is to get the value of x. If I do not get the value of x, then they are not inverses. Okay, so first one we're going to do is going to do f composed of g of x, which means that f composed of 1/2 x minus 2. Compositions are fun. Okay, so wherever x is now becomes 1/2 x minus 2. So we have 2 times 1/2 x minus 2 plus 4. What'd you say? So we're using our composition skills from unit 1.2.1. Sorry, no. All right, so now we're going to distribute. Half of 2 is 1 minus 4 plus 4. What happens to the negative 4 and the positive 4? And I'm left with x. So far we're on the right path. Checks out on that side. Now on the other side, you're doing g composed of f of x, which means you're taking the whole function of f and plugging it into g. So we have 1/2 2x plus 4 minus 2. Again, we're going to distribute and combine like terms. So distribute. We get 1x plus 2 minus 2. And what happens? And we're left with x. So what does that mean? They're inverses. Yes, inverses. Okay, no, we're gonna write one in. All right, but I just want to make sure. I thought I put it on there, but I didn't. How do we feel? Okay. It's always x. They both have to equal x. All right, this is the one that I somehow forgot to put on your notes. We're doing f of x equals 2x plus 1, and g of x equals log base 2 x minus 1. Yes. And we're going to verify. Okay, so on this one, we're going to plug g in first. So we have f composed of log base 2 x minus 1. So that means we have 2 to the log base 2 of x minus 1 plus 1. When you have an exponential raised to its log, it cancels itself out. So we have the same base is going to cancel itself out, and we're left with x minus 1 plus 1.
Where did that come?
Doing this part first, the g of x.
Okay.
And g of x is what? Log base 2 x minus 1. So where x is, it now becomes log base 2 x minus 1. They cancel each other out. If the base of the log and the base of the exponential are the same, they cancel each other out. Got it? And then what happens here? And we're left with x. So that side checks out. Yep. It becomes a coefficient. All right, so we're going to do g of x. So this time is g composed of 2 to the x plus 1. And so we have log base 2, and instead of x, it's 2 to the x plus 1 minus 1. What happens to the ones? Cancel each other out. I have a log of the same base and an exponential of the same base. What are they going to do? Cancel each other out. And what am I left with? X. So are these inverses? Yes. And that concludes. That's it. Yep. Well, you should have been working on the assignment throughout the week.